Hi everyone, this is just a quick video looking at matrices which you started last lesson. So matrices are just an array of numbers and they can have different sizes which we call dimensions. So just for this example, let's take two matrices. I'm going to call one A and one B. Now matrix A, just making these up, let's just put some numbers in like this. And this second one we might put as different. Let's say 5, 2, 1, and 6, -3, and 7. So here's two matrices, just two arrays of numbers, and the dimensions we always go rows by columns. Now just remember RC, shorthand for remote control. If you've got a remote control car, you might see an RC car, things like that. Anytime you see the size of a matrix listed, the first number is always the row. So this first one, matrix A, has 2 rows, so it's a 2 by, and it's got 2 columns, so it's a 2 by 2 matrix. B has 2 rows, and this one's actually got 3 columns, so it's a 2 by 3 matrix. So they're the dimensions. Now, when it comes to operations with matrices, if you're adding and subtracting, they must be the same dimension, right? So A and B, we can't do it because they're two different sizes. If they were the same size, we just add each corresponding entry. So the first one in the first row of the first matrices with the first one in the first row of the second matrix, and we just add those two elements together. So 2 by 2 plus a 2 by 2, the answer would be a 2 by 2 matrix. For this little video, I'm just going to do a multiplication of these two matrices. Now, first thing to check, let's say the question is, does AB exist? And if it does, can you find it? First thing I do is write the AB. So in the first case, A is a 2 by 2 matrix and B is a 2 by 3 matrix. So I write down the dimensions. Now a little quick check is if you're multiplying these two together, the inside numbers must be the same. Okay, if they are the same, then you can multiply. So yes, this one will work. The outside two numbers will be the size or the dimension of your answer, or in this case, dimension of the product, which is AB. So to find AB, it's a little bit more of a complicated process than it is for adding and subtracting. We know it's going to be a 2 by 3 matrix. So I'm going to put up my matrix here. It's going to have 2 rows and 3 columns. And I'm just going to put a little line here for each of those entries. I don't know what they're going to be just yet. Now, what we need to do is, remembering RC is our order, for the first entry in the first row and the first column, we need to multiply the corresponding values from A and B. So we want the first row, because R is first, we want the first row of A, which is all of these values, 2 and -1, and we want to multiply it by the first row of B, which is 5 and 6. So what we're going to do is we're going to go the first one, which is 2 multiplied by the column of B, so it's 5. So it's 2 times 5, and then we've got to add, we've got -1, which is the second one, and a 6, which is the second one in B. So we've got 2 times 5 plus -1 times 6. So I'm just putting our answers out the side here. 2 5s are 10, plus -6 would be 4. Then we repeat this process. So we go to the next one across. We're in the first row still, so we still want the first row of A, but now we're in the second column of our answer, so we're going to actually look at the second column. So for this one here, we're actually looking at the second column and still the first row. So what entry are you trying to fill out in your answer? And then look at those corresponding rows and columns. Remember, rows always first, so it's a row of the first one, column of the second one. So we're in the first row of A, second column of B. So we're going to have 2 times 2 plus -1 times -3. and then we repeat this process. So first, for the next one across up here, we've got the first row, third column, so it'd be 2 times 1 plus -1 times 7. Then we go the next one down the bottom here, second row, first column. So now we're going to be looking at the second row of A. So that'll be the 3 and the -6. So we're going to go 3 times 5 plus -6 times 6, and then keep working your way across. So now we're looking at the second row and second column. So it is 3 times 2 plus -6 times -3, and then second row, third column would be 3 times 1 plus -6 times 7. And now let's just solve all these. So going up to the second one across in the first row, 2 2s are 4, plus 3 would be 7. And then we're going up the top here, 2 times 1 is 2, plus -7 would give us -5. And then down the bottom here, we've got 3 times 5 is 15, plus -36, -21. And then 3 times 2 is 6, plus +18, so that gives us 24. Just got to be carefully positive negatives. 3 times 1 plus -6 times +7. So that's the same as 3 take away 42, which would give us -39. Let's look at how we can use matrices with our transformations. So if you remember, we start with an original point x, y, and we're mapping that to the new equation or the image of x and y. So the transformations are saying what's happening to this original point to get us to the image. Now we can write x and y as a matrix like this, a 2 by 1, and we can say, well, we want to change this somehow. So to change those values, we can multiply it by another matrix, or the transformation matrix, and that will equal our image. So we're doing something here with the transformation matrix to change our original x and y into the image. Now, what size does that matrix have to be? We remember from multiplication, we look at the dimensions. This here is a 2 by 1, and this is a 2 by 1. So the outside dimensions, so the rows of the first one and the column second, will give us the answer here. So because that's a 2, this must be a 2, and the inside have to be the same for the multiplication to work. So this has to be a 2 by 2 matrix. So all of your transformation matrices will be 2 by 2s. Okay, so now what we can do, let's just give these entries here an A, B, C, or D. So when we multiply that matrix across, we end up getting the matrix AX plus BY over CX plus DY. And we can see now that we have equations for our image x and our image of y. So if we're multiplying the x values, we're going to end up having a dilation in the y. If we're multiplying the y values, we have dilation in the x-axis, and vice versa. For the reflection, we're multiplying the opposite values there. So let's have a look at some actual transformations that we know and see how do they line up to the matrix. So let's look at an example where we're trying to apply a transformation, see if we can find out or determine the matrix that was used. So if I have, let's say, the values x, y, and we're going to put a dilation of 2 units from the y-axis and let's say a reflection in the x-axis. We want to find some matrix, a 2 by 2, that's going to change this x into a 2x and this y into a -y. Now notice when we do the multiplications of matrices, we're doing the whole row by the whole column. But in our final answers up here, we don't have any x's in the y values, and we don't have any over here. So we're going to have a range of zeros in our answer. So let's have a look. We want to get something multiplied by this xy, and I'll put it in a different color, a, b, c, or d, to equal 2x negative y. So what we can do, long-winded way of doing this, and as you get used to it, we should be able to just go straight to the matrices once you know the transformations, or been given the matrix, list out the transformations. But if we were to multiply this, to get the first row, first column, I have to take the first row times the first column. So I'd get ax plus by would equal 2x. And I can see, well, there's no y's in there, so therefore b must be 0. And that means that ax equals 2x. So a equals 2. So let's put into our matrix, I've got 2 and 0 there. And then if I do the same for the y, I end up having cx plus dy equals negative y. And I go, well, therefore c has to be 0 and d is going to be negative 1. And that's the transformation matrix that has been used to dilate 2 units from the y-axis and reflect in the x-axis. The shortcut. This value up here, we know is going to be multiplying by the first value of our original, which is always going to be x. So whatever's in the top left corner there is going to be multiplying the x in the image over here. Whatever's in the bottom corner down here is going to be multiplying by your y. So that'll give us multiplying by y in the image. So if I gave you a 2, 0, 0, negative 1 matrix, you should straight away go, well, I know the image is going to be 2x negative y, and then just list off your transformations from there. If we look at a few others, this is where you want to get towards. If you're not quite there yet, that's fine. But through doing some textbook questions and practice, you should be able to just see some matrix. I'm just going to make up a couple random ones here and put in some values. Let's say 3, 0, 0, 1, 1, 0, 0, negative 2, and 5, 0, 0, 3, and let's put a negative 1, 0, 0, negative 1. So here's 4 different matrices, and if the question was asking you what are the transformations that are occurring here, the first top corner one here is multiplying by the x. So I would say this is a dilation from the y-axis. Remember, the dilations and reflections, they're going to swap over. So even though that's going to give us a 3x, we have to say it's coming from the y-axis. Down here, there's a 1. Sorry. And so that's just going to leave it as y. So there's no other dilations happening there. So that's a dilation 3 from the y-axis. Up, looking at part B, same thing here. I'm going to have a dilation of 5 from the y-axis. And the 3 is going to be multiplying my y, so it is a dilation 3 from the x-axis. Looking at question C, I've got a 1 up the top here, so that stays the same. Down the bottom here, I've got a negative and a 2. So remember, we're going to have a dilation and a reflection. So we're going to have a dilation 2 from, now it's multiplying the y, so it's from the x-axis. And we're going to have a reflection in the x-axis. Okay, because that would give us xy maps to x negative 2y. This bottom one here, they're both just negative 1s, so we're going to map to the negative x negative y. So this would be a reflection in both the x-axis and the y-axis. Okay, they do get trickier. Have a go and don't be afraid to ask for help when you get stuck. I'll put a video together with some select textbook questions with worked examples. So if there's any that you recommend, put them in the comments.